Welcome, everyone, to Building Scalable Enterprise Secrets Management with GitHub OIDC and HashiCorp Vault. There are a lot of ways to tackle secrets management, but if you use HashiCorp Vault to store your secrets and you run your CI/CD on GitHub Actions, I want to convince you that this OIDC method is the way you should be handling secrets in your organization. This is an intermediate 300 level talk. You're going to benefit most from this if you're familiar with creating GitHub Action workflows and how to create roles and policies on Vault. But don't worry if you're not familiar with a certain aspect, like GitHub OIDC, for example. I'm going to cover at a high level how this process works and why I like it over alternative secrets management practices. At DigitalOcean, we've introduced this method in the summer of 2022 and have been tweaking our approach since. We're really happy with where we've ended up. And so I'll share some tips and tricks we discovered to provide a smooth experience for developers and expanded oversight and investigatory capabilities for your security or operations teams. So my name is Ari Kalfas, and as I mentioned, I work at DigitalOcean. I run our product security team. We're internal advisors focused on enabling the business to safely innovate and experiment with risks. We do that by guiding secure architecture design and constructing guardrails and paved paths that empower engineers to make informed security decisions. This GitHub OIDC and Vault approach is one example of that paved path. This talk is going to be generic and adaptable for any organization, but I'll share examples of what has worked well at DigitalOcean. Let me start off by saying this stuff is hard. There's no one-size-fits-all secrets management solution. I'm going to be, trying to convince you that, within this use case of GitHub Actions and Vault, this is probably, a really good option, at least. But if you think everything I said is wrong, it's totally valid. I'm going to do my best to explain what I like about this approach and break down the concepts into digestible chunks. So a common concern with secrets management is the secret zero problem. Let's say you store all of your secrets in HashiCorp Vault. Now, of course, you don't want everyone to be able to access every secret in Vault. You want to segment access, and so you create Vault roles, and you give out credentials to each Vault role to the appropriate teams and users and services. So where do those authentication credentials to Vault get stored? You can't store them in Vault. You need them to log into Vault. This initial credential pair, these login credentials, to your secret store, that's commonly what's known as the secret zero problem. You could store them in another secret store, but then how do you protect access to that system? You need a new pair of login credentials. It's turtles all the way down. And so our goal is to ensure our workflows stay protected. Let's assume breach, which is a security mindset that, kind of threat models how to respond when a breach occurs. We don't want to just prevent a breach. We want to minimize the impact of a compromise if it occurs. So let's suppose our GitHub environment becomes compromised. How do we mitigate that impact? Well, all right, first thing then, we can't store our secrets in GitHub Secrets. Thousands of static, long-lived secrets in GitHub Secrets. A compromise there has devastating impact across the business. Plus, they don't support versioning. But putting all of our secrets in GitHub Secrets, that's just not going to work. We don't have any way to minimize the impact of a compromise. So we'll store all the secrets in Vault. And let's say to solve our secret zero problem, we'll store the login credentials to Vault. We'll put those in GitHub Secrets. So we're reducing the number of secrets that get compromised. Is that going to work? Well, let's say my picture here, let me add it, is a little unfair. I like CircleCI. I use them for a few personal projects of mine. Big fan, of course, of GitHub Actions. I don't use Travis CI. I feel it's a bit unfair of me to place CircleCI next to Travis here. But let's explore solving the secret zero problem by putting our Vault credentials in GitHub Secrets. I don't really think that works. I think that requires orgs to implement really complex management procedures. Any secret system should be able to answer the questions: what roles are used by which repositories? What secrets can Team X access across all their projects? Is Team Y's access too broad or too restricted? Can you demonstrate adherence to compliance requirement? Let me hear my Sarbanes-Oxley fans in the chat and demonstrating protection of privileged credentials. GitHub Secrets doesn't provide a method for orgs to answer these questions. You have to build something yourself on top of their APIs. Either then you're constructing a sprawling asset management system for your login credentials, or you give up and accept the risk this lack of visibility poses. And I'm picking on GitHub Secrets here because it is the native solution offered inside of GitHub Action Workflows. So it's the natural thing to compare against. So what is the lifecycle and rotation strategy for vault credentials that are stored in GitHub Secrets? Let's say a role credential is compromised. How do you determine all the locations it is stored? You can delete it, I guess, and see which developers complain about a broken pipeline. I think it's a pretty poor experience. Is the security team, building something and providing resources to help teams manage those credentials? Or are you leaving each team to figure it out for themselves? The granularity of what can access a GitHub secret. You have repo level granularity. So what if you have non-prod and prod credentials that need to be used by different workflows in a repo? GitHub environments do provide some assistance here, but they're a bit too limited in what they offer. And what if you have multiple teams working together? At DigitalOcean, we have a central monorepo. And so we have multiple teams working together, and they should not be able to access each other's secrets. That's a pretty big concern we need to address. And what if you have reusable workflows or GitHub actions that need secrets across your environment, across your organizations? How do you manage granular access in that case? Do you store then the secrets at org-wide global level? Do you duplicate the values across repo level secrets? There's no real smooth answer there. Anything is going to provide a lot of friction. OIDC gives us a ton of really fine-grained options, so we'll explore those shortly. And then how are you auditing access to secrets and GitHub logs? I know GitHub has repo and org level events emitted to their audit logs for creating, updating, or deleting secrets. I don't believe they have any audit events around access of secrets. If you're attending live, let me know in the chat if you found anything useful in GitHub log for this. I really like the metadata that we can attach to Vault audit logs when we use OIDC. We'll take a look at that. And at the end of the day, static secrets in your workflow of any kind are bad news. Our workflow is compromised, and our Vault role credential is compromised. We've moved all of our secrets to Vault, but we just added one real minor hop for someone to still access all of that, just accessing the Vault role inside the workflow. Sole credentials continue to be a really significant factor in breach incidents. With OIDC, we can set really short time to lives on the auth token and really significantly reduce the amount of time a compromised workflow exposes a Vault token and poses a risk to the organization. We can set the TTL to even just be seconds and not impact developers. It's really nice. So I'm setting up OIDC to sound like this really incredible, miracle cure-all. What is it? OpenID Connect is a way to authenticate a user or service to a third-party identity provider. In this case, that identity provider, the cloud provider in this image, that would be Vault. And it does that using a JSON web token. Instead of managing login credentials, the token exposes parameters known as claims, which we can bind a Vault role against. When GitHub presents a token containing the necessary combination of claims, Vault will give you an auth token for that role, as long as the claims match what we've expected for that role. When we say the JWT contains parameters that we map to that Vault role, these claims are key value pairs of metadata. And by the way, all the code snippets in this presentation will be in Terraform because that's how I manage Vault, and I didn't want to look up how to do these with the CLI or the raw API. But in this image here, in these two images, the repository and actor fields, those are two claims present on the JSON Web Token. And you can bind a vault role to any combination of claims inside of the GitHub token. A bunch of these aren't really going to be useful for Vault OIDC bindings, but they are, options. And then to log in, you typically are going to use HashiCorp's Vault Action GitHub action, which they maintain. To log in with OIDC, you pretty much just ask for your vault role by entering its name in the role field. And as long as your GitHub JWT matches, along the claims in that JWT match the expectations you've configured for that role, you just get a vault token and all of your requested secrets. Easy as that. This eliminates the need for developers to manage static credentials. You don't need to worry about rotation, no lifecycle management. There's no more duplication of credentials. You can't lose these credentials. All of these are just eliminated problems. And this brings me to the main point of this presentation. 11 minutes in, we're done. OIDC gives you a ton of flexibility to design really fine-grained, least privilege, role-based access control, account-based access control, things that you'll enjoy. At least you'll probably enjoy it more than this word soup of a subtitle. I was looking for a third thing to put in the subtitle, and I came across PBAC. I was like, what is that? Turns out it's policy-based access control, which, kind of sounds like every type of access control. I suppose it's probably differentiating from YBAC, which is YOLO-based access control, which I also call Equifax. But OIDC unlocks a ton of flexibility. And you kind of transition your mindset from creating a login credential for your project, then going off and using that credential however you need for your project, to creating a vault role for each use case you have inside your project. So for example, let's say you want non-production secrets to test code inside pull requests. Cool. You get one OIDC vault role for that. Now you need production secrets to deploy code from the main branch to your production environment. Cool. Another OIDC vault role. And, we have our teams collaborating inside a monorepo and each need their own services set of credentials inside each workflow. Great. Vault role for each workflow. This creates a lot of vault roles to manage. We'll talk about how we do that at DigitalOcean, but I view that as a much simpler concern than the management of static credentials, the lifecycle, the rotation, all that. So here's how each of those three use cases would look as an OIDC binding. And so I hate calling things in tech simple, but after getting over the initial kind of learning hump of understanding the OIDC bindings and what's available to you, after familiarizing yourself with the JWT components, I'd say the configurations required are not complex. I hope these screenshots demonstrate that. For example, here we're saying, all right, pull requests from the artisan/myrepo repository can access this vault role. Great, only pull requests. Here we're saying, we want production secrets from the main branch, so the main branch in artisan/myrepo can access this vault role. Done. And we can combine, again, any number of the token claims, and they all have to be present in the JWT in order to receive an auth token for the vault role. Due to our limited time today, I'm not going to go over the different formats for how claim values can appear, like how the subclaim is kind of changing across these use cases, or how this job workflow ref URL is constructed. I have resources listed at the end of the talk that explain this content for those who do want to learn more. But I'll say nearly every use case can be bound to some combination of claims in the GitHub JWT. At least every use case we've come across with our developers at DO, they've been solved for with just a handful of common claim patterns. And so, okay, this looks pretty cool, but it sounds like you have to configure a ton of vault roles. How do you manage that at scale? It's one thing to set up a Hello World example on a single repository. It is, yet another to construct a program scaling to hundreds or thousands of repositories and developers. As I see it, there are three main aspects to successfully scaling out an enterprise secrets management program like this. You have to, number one, reduce developer friction. You can't introduce something that is going to make it harder for developers to get their job done. You got to make the security option the most convenient and useful option for engineers to adopt. And that means you need to, number two, encapsulate complexity. Does every single developer need to understand the intricacies of the OIDC claims? Security should be providing structures on top of that. And you need your oversight and auditing capabilities to be performant and actionable at enterprise scale. What information can you put right at hand of incident responders? And how is that going to kind of reduce the amount of time an investigation would take? So you have to reduce developer friction. Fine-grained, least privileged, tightly scoped vault roles is amazing for security. Sounds like a lot more work for developers. Also, any misconfiguration between Vault and GitHub Action workflows results in a vague 400 error from Vault. That's not a great developer experience. Security needs to take a contextual, developer-first mindset to rolling out a program like this. Invest in a paved path. Developers should get their secrets and be able to move on with their day. They shouldn't need to learn the internals of OIDC claim construction. And I really like this image when talking about security programs. I've seen security professionals put out some set of rules and then argue with engineering when they don't follow the rules correctly. It's not the developers doing the thing wrong. The security initiative has been designed incorrectly. We've made it wrong. With that mindset, how do we develop a program that works, that developers will latch onto? And I'm going to use concerns instead of problems, because a problem sounds like something a developer has caused, when in actuality, the security program is not meeting the needs of developers. So how do we meet those needs? We don't have to start with large, grandiose investments. Attention to the little things will go a long way to improving the experience of interacting with the security system. So at DigitalOcean, we vendor that HashiCorp / Vault Action, GitHub Action. We vendor that internally and set company-wide defaults on behalf of devs. So you don't got to put in your Vault URL or CA certificate, things like that. By default, the action puts secrets into environment variables. We prefer folks use the step outputs instead, like in this example. So we set those defaults in our vendored action. So devs only need to modify their unique configuration. They request their secrets, ask for their vault role, and we choose that as them to customize their audience as well. And as a little Easter egg, if you notice, we're using Packer in this workflow run. We got Vault, we got the Terraform, we got the Packer. We're HashiStack folks. So, encapsulating complexity, asking every developer to learn the intricacies of the GitHub JWT, bound subject filtering conditions, or impacts of combining multiple claims. It's going to lead to a lot of frustration. The internals of OIDC claim construction should be encapsulated through tooling that makes it easier for developers to get the correct vault roles for their use cases. At DigitalOcean, the security team offers a command line wizard that interactively walks a developer through the steps to create a vault role for their workflows. It generates the GitHub Action workflow files for them with the correct workflow triggers, permissions, and steps all built in and configured, ready to go. This not only provides a paved path for the secrets management that security cares about, but makes it faster for developers to deploy their engineering pipelines. So win-win. We're solving the security problems alongside the developer ones. Crucially, developers are not asked if they want to do security task A or security task B. They're not expected to understand the intricacies involved in making that decision. We're encapsulating those for them. Instead, developers are asked which engineering task they want to perform, and the tooling guides them through the relevant security steps for that task. And our oversight and auditing across the enterprise. We customize the bound audience with the format org repo team service. So that data is Also, if you see it in the role names that we generate, so it's kind of redundant, but it's easier to filter on. So we can tell that this role is associated with the DO Golden Images repository from the chef team for their Golden Images service. And this information, the audience, it's bound into the OIDC claim expectations we have for the vault role. So it has to be present in order to successfully authenticate. The auditing capability I like the most is the user claim attribute. The user claim is how Vault uniquely identifies clients. Its value becomes the entity alias when you log in, which means the user claim is the display name attribute underneath the auth object in Autologs, auth.displayname. The user claim can be any of GitHub's JWT claims. Many examples use actor for the default user claim, but that does not produce actionable information for an enterprise auditing standpoint. I don't like it. As a little tangent, the actor field in the GitHub context is always the very first thing that triggers a workflow. If a user or dependabot or whatever triggers a workflow and then someone else reruns the workflow, the actor attribute remains the original thing. GitHub recently added a triggering actor field to their GitHub context, and that distinguishes who is currently running a workflow versus who originally ran the workflow. But the OIDC token's actor claim is always the github.actor context. So that's ambiguous. We don't like that. Instead, the job workflow ref gives us detailed and actionable metadata on Vault Autologs. And so these are those Vault Autologs. This is a confusing image, but the only way I could get this large enough to be visible for y'all. The right side of the top image continues from the left side of the second image. And so the Vault Autologs show, the scoped secrets, the production secrets that they're accessing from this specific repository, the chef repository, from the produce chef container workflow file, and we know it's from the 43249 pull request. And remember, the auth.displayname, that's the job workflow ref claim from our token. So this is a ton of really useful data that lets us zero in on actionable information if we needed to run a security investigation. And with this workflow information, we could always correlate it to a GitHub triggering actor if we needed to. And don't forget, it's, nearly impossible to misuse this vault role. Its intended use has been bound to the JWT claims, and any inappropriate attempt is just going to fail to authenticate and receive any secrets. You're not exposing anything. And finally, we have not found a developer use case that needs a vault token longer than 5 minutes, but you can set the TTL to be, whatever you like. 80 to 90% of our workflows don't need a vault token for more than 15 seconds, but we set 300 seconds, which is 5 minutes, by default to kind of account for those additional edge cases. If your app needs perpetual access to Vault, you can store app role creds or something in Vault, retrieve them with OIDC in your workflow, and pass them to your app on startup. So inside the workflow, you only need access to Vault for just a few seconds to grab your secrets. So you have been enamored throughout this talk. You want to take action on these ideas immediately. Where should you go to learn more? First, we've open sourced a Terraform module to help organizations configure this OIDC authentication between GitHub and Vault, and help manage the sprawl of OIDC Vault role bindings that spring up. Takes all the learnings we've gathered and applies them as best practices and default settings on this module. The 5-minute TTL, the job workflow ref user claim, and others are all there. You can customize beyond that if you'd like. To help kind of manage that sprawl of OIDC bindings, we have a JSON files example there that lets you kind of apply those as across distributed JSON files. So take a look at that. And now you may be sitting here thinking, well, we're nearing the end. There were some slides with code, but come on, a talk at HashiCorp without a demo? I did you one better. I wrote an interactive, hands-on course so you can do the demo yourself, on your own time, at your own pace. Completely free, self-contained inside the GitHub repo. You can configure OIDC bindings on Vault and GitHub Action Workflows to retrieve secrets. Takes roughly an hour to go through. You'll build 3 workflows based on real-world use cases. Additionally, it didn't make it for this recording, but by the time you are watching this at HashiTalks or afterward, there should be an article published under the security section of our DigitalOcean blog. That article is going to go a lot further in depth on the concepts I've highlighted during this talk. It covers 5 use cases that account for the majority of the OIDC bindings that we configure inside DigitalOcean. A lot further explanation on everything in here. Check it out. And Ned Bellevue has a great talk at HashiConf Global from 2022 about GitHub OIDC and Vault. I encourage everyone to check that out as well. Thank you. I'll be sharing this slide deck on discuss.hashicorp.com with the rest of the 2023 HashiTalks decks. Check out the GitHub skills demo, and I hope you have a great day.